All right, Algebra 2, welcome back, guys. We are in Section 7 today. All right, Chapter 6, Section 7, all about graphs of polynomial functions. It's going to be a pretty quick video. All right, so let's just jump right into it. You will need the graphing calculator, so make sure that you have that with you. It's going to help out with a couple of the example problems. And I'm telling you right now that these charts that you see in front of you here, you got graphs of polynomial functions. That's very, very helpful. And the one underneath it there, polynomial in behavior, you're going to have this chart also. All right, so both of these charts are going to be utilized throughout the homework. And then let's go ahead and just make sure you see the overall shape that you're looking at with this chart right here. That's what we're focused on, all right? Not every single problem is going to give you a graph that looks identical to this. I hope you understand that, but they will look very, very similar to these graphs. So that way you can see a graph like this giving you a degree right here, or a graph right here giving you a degree right there. And something you may even want to make a note of is just that the degrees could be odd or even, because part of the homework is just going to say, is this an odd or an even degree type of graph? And you'll see what that looks like. Okay, the next one for polynomial in behavior, I kind of color coordinated this to make sure that you guys could really see what I'm talking about. So like the little note off to the right-hand side says, focus on the lead coefficient and the degree. That's the main things that you're focusing on. And that way, when you see that, then you look back at this chart and you're looking, is the first number a negative? Okay, well, then those are on the bottom. Is the first number a positive? Okay, those are the ones that are on top. And then odd or even degree, meaning is it an odd or an even exponent that is with the lead coefficient? Okay, so there's that. And a little bit more info here. Okay, so when you're asked to graph, of course, use the graphing calculator, and then they're going to ask you, what's an estimate of a local maximum? So that's going to be the highest point right before it drops back down again. Okay, so we're talking about this guy right here. So it goes up, reaches a point, and then drops back down again. That's a local maximum. A local minimum point is going to be when it drops down, reaches a bottoming out point right before it comes back up. Okay, so that's this guy right here. Now, when they ask for the estimate, you're going to use the tracing button on your graphing calculator. Okay, so that's in the upper right hand. It's the button right next to graph. So you're going to use the tracing button and you're just going to get an estimate. Okay, so the more zoomed in you can be on a local maximum or a local minimum, then the more accurate your estimate will be when you're using the trace button on the graphing calculator. Okay, so let's do some example problems. All I did, that chart right there, it's the same chart as above. I just wanted to have it in view so that you could see it as I'm doing the example problems, so that I could see it also as I'm doing the example problems, because we're going to need that. All right, so identify the lead coefficient, the degree, and then state the behavior. All right, so the lead coefficient, that's going to be this guy right here. It's a 2. And then what is the degree over here? That's a 5. Okay. So what we're focused on is that the lead coefficient is positive and the degree is odd. Okay, so when we have that info right there, that's going to allow us to then say, okay, degree positive, so we're sticking to the top part here, and then, lead coefficient positive, and then the degree is odd. So this is exactly what we want. Everything in there, okay? So all we're going to state for our answer is what you see here. X goes to positive infinity. Then we are saying P of X goes to a positive infinity. Same thing down here. Now drop to the bottom as x goes to negative infinity, p of x goes to a negative infinity. Okay, so all I did, honestly, is just recopy what this is right here. That's what it's asking you. That's it. You just have to know which part of this chart am I using. Okay, so let's take a look at example B. So we have a negative lead coefficient and an even degree. So negative, we're looking at these guys, and then an even degree, so it's this box right here. Okay, so that's the box that you're looking at, and all you are going to do is copy this info right here and this info right here, and then go ahead and copy that info down here. All right, I'm going to save you the time. We don't need to recopy that like we did in A, but that's what you're doing. Use the chart, copy the info. They're going to say, what is the lead? It's a -3. What's the degree? It's a 2. So we know it's a negative lead, even degree. Use that part of the chart. Okay, so there we go. Let's go ahead and take a look here. Second part. All right, so from the graphs, by the way, these two example problems, you're going to need the info that comes from this chart right here. Okay, so using these graphs, you're going to tell if the polynomial would have an odd or an even degree. You don't need to say what the degree is. You just need to say odd or even, and then is it a positive or a negative lead coefficient. Okay, so when we take a look at A and you look back at that chart, you're going to see that that shape for A looks very, very similar to a cubic function, which has a degree of 3. So 3 is an odd number, so we're going to say this is an odd degree. Okay, second part is the coefficient. Is it a positive or a negative lead coefficient? Okay, now what would be helpful is look at the chart right here. Looking at this chart, this part right here. Okay, and let's take a look at which one makes a shape like that. Is it a positive or a negative? And it's going to be a negative coefficient. Okay, so a negative coefficient would make that shape. Take a look at that chart. That's the one in the lower left-hand side. Very, very similar to that. All right, let's take a look at B. Look at the chart, and it looks extremely similar to a quartic function with a degree of 4. So a degree of 4 would be an even degree. Okay, and then anything that has an even number for a degree, if both arrows are pointing up, then it's positive. If you had an even number degree and both sides have arrows pointing down, then it's negative. So this one is positive. Okay, so there we go. That answers that. Let's finish this out right here. So number 3, just graph that with the graphing calculator. Simply enough. Plug it in, find the graph it for the homework, so we don't need to worry about that. But the second one, all right, so for number 4 here, it says graph it and estimate the local maximum and minimum. All right, so I've already graphed on the graphing calculator. You need to do the same thing. So what you're doing is you are taking this right here, plugging it into the graphing calculator, and you want the local max and you want the local min. Okay, and then how do you do that? You're going to use the trace button, which is right next to the graph button. Okay, so when you do that, let's see what we should be getting here. All right, graph it, and looks like I had a different graph in there, so give me 1 second. Okay. So then you're going to see a cubic function. And when we go to trace and we get to the, I'm going to go first for the maximum. I get a value of about, let's see, should be, zoom in here. I get about negative 1.98 for the y value, because that's what we're going for the maximum and the minimum. You know, that's the peak and the valley. So a negative 1.98 for the maximum, and then let's use that trace feature and move. And for the minimum, I get about a negative 4.04. Okay, so if you can go about 2 decimal places, that's good enough. All right, so that's going to cover your maximum when you trace, your minimum when you trace. If you guys have any questions, of course, bring those to class. All right, I will see you guys in the next one.